Alright guys, today we are going to be creating the program that I mentioned in the video before. So the first thing is that we're going to be creating this program in C++, which means that we're going to be creating it in Microsoft Visual C++ 2010. If you've got Visual Studio, awesome, but for those of us who don't have a few $100s to drop on Visual Studio, you can grab a copy of Visual C++ 2010 Express for free online. Now, the only other thing that you're going to need for this is that you're going to need the latest version of .NET Framework. I think maybe it's .NET 4.0. Once again, that's free too. So once again, just Visual C++ 2010 Express and also the latest .NET Framework, and go ahead and get both of those installed, and you'll be able to run Visual C++ 2010 Express, or whatever the current version is. I'm sure it's past 2010 at this point. And it should still be similar though. So all I did was went to File and New Project. We want to create a new project. It's going to be a Win32 console application. I'm going to name our project Autopilot. And of course you can name it whatever you want. But for me, I'm going to name this Autopilot. I'm going to go ahead and do OK. Now it's going to have a secondary wizard here. It's going to ask me a little bit more about the program we're doing. In this case, I'm going to do, actually, I don't want to do an empty project. I'm just going to do a pre-compiled header, and it's going to be a console application. So I'm going to go ahead and finish this up. And as you can see, it gives us a basic sort of layout here. Now, what I am going to do for the sake of this video is actually remove some of this information it gives us here at first, because I already have a copy of this program already made, so I'm going to save us a bunch of time. I'm going to copy over our standard includes and standard includes. So these are going to be the files that the program actually needs to include to run. The next thing I'm going to do is go ahead and copy over a few functions here. Now these functions I'm going to go ahead and toss on the bottom of here, but you have to actually you have to kind of initialize them or pull them in at the very beginning here. So just as an FYI, these different functions, if you don't know anything about programming, it's the same thing in Java as well. So you've got whatever you're calling up here at the top, this void or boolean right here. At the beginning of your function, you have to tell the compiler what if it's going to return anything or not. Sometimes you're going to give it, like, say, two integers right here, three integers, like we have right here. We have three different integers that are going to go into this function, but it's not going to return us anything, which is why we say void here. Because instead of it, the move mouse function here is not actually going to return anything, but instead it's actually going to do something. So it doesn't need to return anything. On the other hand, on our functions that are actually looking for us, remember in the video before I said, the program is going to have to actually look for us as well. That's where these come in. These are going to return true or false for a given pixel coordinate. So it's going to look at a pixel color, and it's going to tell us if it's a yellow pixel as we defined it in the function, or rather it's not. So it's either going to be true or false. Now on isBlack, this is actually a little bit different here, because this isBlack is really is white. It really is gray, because uh, every color that is between black and white that is a variation of gray all have something in common, and that's that the red, green, and blue colors are all equal. So that's something to keep in mind. Now the other thing that we're going to have to do here as well is we've got just another variable that we want to declare here, and that's going to be perm_y, which is going to be 0, and we have to declare as well that we're going to have a window. This is going to be our EVE window, or really just any game window. You'll see that later. For the sake of this video as well, I'm going to modify the main function here. the place that I'm copying this from, you're going to be able to pull it up. I'm going to include it in a link down below, all the source code, so don't worry about that. Now I'm going to go ahead and pull over all of our basic functions here, and we're just going to go through them, okay? So these are just going to be the different parts of the program that we outsource to different functions, which are going to do something and then come back to the main program. So for each one of these up here, we're going to go ahead now and place them down below. So now you see we have quite a bit more text. We have still our main program here, which doesn't have anything in it yet, but now we've got our functions. So as we can see here, the press key function takes a word key or a word code. I'm going to put a link to how you would actually get these, because pretty much the way that this works is that you're going to have to tell it the code for the key that you wanted to press. And then this X, I just put it in here. This X is just the number of times that you want to press whatever key this is. It's just a quick way. And if you look in here, all this programming code, all it is just a fancy way of saying take this key code that we put in the first part as our first point of data right here, and press it the number of times that we specify in the second data field right here. Alright, that's all this is. It's going to press a key on our keyboard. Now for mice functions, we have something a little bit different. We have a click button or a click function, which is going to click our mouse at a given coordinate, a XY coordinate. It's only going to click once, so it's going to do left key down, and then 100 milliseconds later it's going to go ahead and do an up event. So down, 100 milliseconds later up. Alright, that's what it does. But the first thing it does, of course, is brings our Eve window to the foreground. Alright, and once again, like I said, you can repurpose this set foreground window for really any window you want. The double click is pretty much the same thing as the single click, except for you'll notice that it, down up, then it waits 200 milliseconds, then down up. That's all it does. Right click does a single right click, but it does it with the right mouse button. So you can see it does a right down event, then a right up event. Alright, very, very simple. Then click down clicks down in a certain coordinate here, but it leaves the left mouse button down. And click up does the same thing, except for it's the opposite of click down. Now you would use both of these if you're trying to click and drag something somewhere, okay? Because you can notice we still have our coordinates that it takes up here, right? So we're going to move the mouse to a certain place, and then we're going to click and drag the mouse to a certain coordinate. So click down in one coordinate, move to another one, then click up in another place, and it's just regular left click. So and then we have move mouse, which really brings all those mouse functions together, because we're going to tell it where we want the mouse to be. We're also going to tell it what type of click it's going to be, okay? So this is going to determine which one of these functions, click up, click down, double click, whatever the case is. This third data field right here is going to tell it what to do with that. And if you scroll down here, you're going to notice that we have to do a little bit of calculation here, because the thing is, your screen starts off at 0, 0, 0x, 0y in your top left corner of your screen. Now, as your cursor moves down, it adds 1 to the y variable, or the y coordinate. If you take algebra, you'll kind of know, or if you took algebra, you'll kind of know what I'm talking about. Then the further over to the right you move, the more you add to the y, and I think the further vertical is x, or maybe vice versa. But of course, computers are much better at this stuff than I am. So, you can see here, get cursor position, very, very self-explanatory. It gets the cursor position. Then it takes that, and then it tells us where the mouse is on the X coordinate and the Y coordinate. Now the reason we have to do some calculation here is because your window, your gaming window, and I'm going to recommend that you have your game window in windowed mode for this purpose and not in full screen, which I know most of you would like to do. I would like to do it myself, but at the same time, I don't necessarily want to go around clicking repetitively between jump gates and whatnot. So I have my window, my game in windowed mode, and that's so I can more quickly tell where the coordinates are that I need to click on when I'm programming certain things. Now, you may be a Uber programmer and you may know how to set that in full screen. You may be able to do that. That's fine. I'm definitely not the best programmer out there. Uh, so, and all this does here is this cycles through and it moves the mouse. All right, so it's going to move the mouse from one place to another. All right, that's all this stuff is here. Now, once it actually gets to the coordinate it needs to go to, then it actually hands it off to the either click mouse, right click, double click, click down, click up, all that stuff. So, this function is going to be the function that moves our mouse for us, and it's going to move it based upon time and also what it sees. Now, based upon what we see here, the functions that are going to be responsible for that are going to be the isYellow. Of course, you can change this to whatever. Of course, really, it would be very useful for you to know the exact color of what you're looking for. But you know what? Don't worry about it, because I'm going to include in the package a program that does so for you. All you have to do is move your mouse to a certain place on your screen, and it will tell you what the RGB code is of wherever you have your mouse pointed, wherever your cursor is pointing. So, of course, I'm going to look out for you. And it was very helpful for me too. So, of course, I'm all about helping people out. Now, isBlack, as I told you, is a little bit different. If we look at the isYellow and isBlack, you'll notice that they're just about the same. Now, this particular function does not move the cursor to any place on the window. All it does is look. So it's going to look at the X and Y coordinate that we give it in relation to our window position. Alright, and once it does that, then it's going to pull up the color and it's going to compare it to our information here. Now, for isBlack, as you'll remember me mentioning, it's not so much a isBlack as it is a isGray, white or black, because white and black and all the shades of gray are all equal. So, and when I say are all equal, that means that the red, the green, the blue colors are all equal. So our logic test here states that if red equals green and if green equals blue, then pretty much it's true. It is a shade of gray, or it's either white or it's black. Now, if it's not, then it's going to return false. All right, so very, very simple. Very, very simple. So now that we've gotten all the functions and everything out of the way, let's go ahead and look at the actual program here. And I'm going to go ahead and pull over the first part of the program, which is really nothing more than just a test to make sure that the window is open. If you look here, first we established that we want our SRAM to be built off of the time of the day. You either may or may not want to do that. It's up to you. SRAM, of course, is pseudo-RAND because, I guess random numbers aren't theoretically random when they're on a computer. Then we have to initialize our mouse pointer. Then we also have to initialize the window position. The next thing we're going to do is to find our window with this name. In the case of Eve, ever since like a certain update back in the past, they changed the Eve window names to fit the pilot name as well. So it's going to be Eve, all caps, then a space, dash, then the pilot name. Alright, so you're going to have to change this part to whatever your window name is. Then it's going to say here, if that window is null, which means that it doesn't exist, it says it can't find the Eve window. Make sure that Eve is open. Alright, very simple. Then it's going to pause and pretty much pause indefinitely. The program is going to stop. Now, if you set the foreground window, set foreground window, very simple. It just sets the active window to the window that we specified above. If this isn't the case, then it sets the foreground window, sleeps for 2 seconds, then it gets the information of the window, the coordinates and the size and whatnot, and then it also gets the cursor position and says everything checks out. So let's begin the journey, right? And if you know anything about programming as well, this is in 101. /n is just the way that the compiler reads enter key. So as I do enter like this, that's really a /n. Alright, now I'm gonna go ahead and go to the first loop in our program. Alright, now this loop is based off of the way that my Eve game is set up. Okay, in part 3 I have footage of this bot in progress as it goes from Amar to Jita, and you have to set up your windows to be in static locations. They have to be in a place where they're gonna be, and the reason for that is because your program here is gonna have to know that it can look at certain pixels on the screen and for sure make a decision off of that. So if your windows are shifting, or if you have windows set up in different places and they change whenever you undock and dock and stuff, well, you're gonna have to reprogram the program every single time. So anyways, like I said, that's how I have mine set up. You can take a look at video number 3 and you'll see what I'm talking about, or part number 3. So the first thing that we're going to do is set a Boolean integer, which is going to be true, running. Alright, then we're going to start a while loop that says while running, that we just declared above, is true. Then we're going to do the following. So first thing is scroll up is going to be false. Now you'll understand the purpose for that later, but you see we got a few different loops here, because pretty much when you're going from one station to another, believe it or not, all you're doing as a person is just doing loops. You're looking for yellow on your screen, then you're clicking on that yellow, then you're pressing warp, warp to 0 and jump, and then so once it's over again, then you do the same thing over and over again. So that's all this is doing. We just got a series of loops here, a logic test. So you're going to notice that we have 3 different loops, 1, 2, and 3. Now that was for me because what I noticed was that it seemed like it wouldn't pick it up sometimes in one loop, but it would pick it up in the other. Where right here we have 770, 771, and 772. This is because it looks at 3 vertical lines of pixels in my Eve game window. So it looks at 3 of them, and then it cycles through those. So you're going to see here that I is going to start off on 193. All right. Now the reason why I equals 193 is because that's where the beginning of that particular window that shows me jump gates and stations, that's where it starts off in my Eve window. Once again, if you look at it on the part 3 of this video, you'll see kind of what I'm talking about. Now you're probably wondering, how do you actually get that? Alright, and the way that you can get that in Windows is actually very simple, because all I really have to do is go to MS Paint, and then what you're going to notice here, and I'm pulling the window up and I'll show you what I'm talking about. If you pull up a MS Paint window, what you're going to notice is right down here, this is going to show you where your XY coordinates are. So you can see how as I move my mouse, it changes. It shows me my X and my Y coordinates. Alright, that's exactly what I'm looking for, my X and my Y coordinates. So one of the reasons I tell you to run the game in window mode is because you can take a screenshot of the game window, and then from there you can just paste it in the Microsoft Paint or MS Paint, and then you can move around the game window and you can actually find your coordinates based off of that. So very, very simple. That's all you have to do to get these X and Y coordinates. So, as we can see here, it looks at vertical line 770 going down, and it's gonna search under I. So 770 and then I on every screen. It's gonna go down and look and see whether it's yellow or not. Now, what happens is that once it goes to the bottom of this loop, if it couldn't find it, then it's gonna add 1 to I, or I++, at the end of every loop until I is equal or greater than 474. Once that's the case, it goes on to our next loop, which then looks one more line to the right. Once again, I was having a little bit of an issue with it not finding certain jumps, so that's why I have 3 different vertical lines here that's checking. So then it looks on 771 and does the same exact thing. And what happens here is that if it does successfully find it, then it's going to actually get out of this loop. And it's also going to declare that the other loops are invalid, which is why it tells them all false, because all these are while loops. So which means that while the condition inside of the parentheses is true, then it's going to do the loop. But if the condition was never true, then it'll just fly through all of these, all right? Now, that was our first loop here, which is why I say found point in loop 1. This is actually what it's going to give us in our console window when it finds yellow in the area that we're looking at here. Now, the next thing that I'm going to put here is our second search, all right? Now, the second search is a little bit different, and I'll tell you why. And that's because what it actually has to do on the second loop is if it looks through all of these areas in loop 1 and it can't find it, then it has to actually go down to the bottom of the window. In certain solar systems in EVE Online, let's say for example JITA, there's so many stations in JITA that your list will go off of that first screen. So the purpose of the second search here is to go down to the bottom of that window. First it's going to move mouse, and it's going to do move mouse 1, which is going to be a single left click. It's going to click on one of those bottom locations in the window. Then it's going to press the down arrow a few times, all right? Then what it's going to do is do a new loop similar to this one. So it's going to search for yellow again, but just on the bottom of the window, because like I said, sometimes the solar system is so large that the location you're trying to jump to may be off of the bottom of the window. All right. So just once again, just letting you know how this works. That's the reason why the second search is different from the first search. And you can look at the logic here. It's not too hard. Like I said, it's going to click on the bottom of that window, and it's going to press the down arrow a few times. Then it's going to search for yellow again until it finds it. All right. It's going to find it in this last loop. Now, once that's done, then we're going to go down to the actual meat and potatoes of what's actually going to have to happen here. All right. And that's that, this program is going to have to look, and it's going to have to find out based on the coordinates that we found that yellow is. It's going to have to actually click on that, and it's going to have to take action on that. Okay. So the first thing that it's going to do is move the mouse to, because our warp button is in this vertical line in our game, so it's in the Y. It's on this particular coordinate. Now, as far as Y goes, it's going to get that from whichever one of these loops. All right, so it's going to try and find the horizontal line equivalent underneath this X coordinate. All right, so it's going to click right next to where it saw yellow, and it's going to click on that. Then it's going to move the mouse back up to the top to where the warp button is on my game. And like I said, you can see it in part 3. First it clicks on the line that it saw yellow, then it clicks on the warp button. All right, then it sleeps for 100 milliseconds. Now if scroll up has to be pressed, and the reason it may have to be pressed is because you're going to notice here that if it went to our second loop, then remember it had to press the down arrow a few times to actually find the position of where yellow was. So what the game is then going to look at, or the program is going to look at, is it's going to have to look at the very top line, because the way I have mine sorted is that the closest station or jump gate to me is going to show up at the top of my list. So this program is going to wait until yellow appears on the top item on the list. Now it can't do that if it had to press the down arrow a few times and it moved off of the very top of that list. So the purpose for this part right here that says scroll up is that it's gonna go on the window here, and it's gonna scroll back up to the top of the list. So it's gonna press the up arrow about 30 times, which doesn't take long because this is a program, and it we can tell it to press a button very quickly. And then once that's done, then it sets scroll up to false. So it'll go ahead and get out of this loop. So the next thing that it's going to do is look to see if that top line is yellow. All right, the top line being the top jump gate or the top station in my window area that I set in my EVE Online game. Or it's going to check to see if the screen is black anymore on the middle, normally where your life gauge is in the game for your ship. It's going to tell you if that area is still black or not. Now if it's not black, it's going to assume that you docked in a station and it's going to be done. Alright, now once it becomes yellow, then it's going to look to see when that item is no longer yellow. And the reason for that is because once your top line item is yellow, then you know that you're very close. All right, the program knows that you're close. Now once that disappears, then either one of two things happen. Either you're in a station or you've jumped to your new system and it's going to wait for a while. All right, so it's going to sleep for 2.5 seconds here once that yellow disappears, or once the bottom is no longer black. Alright, and the reason for that is, like I said, either it's went in the station or it's warped to the new system. Alright, so our last step here is if the bottom of the screen isn't black or white or some sort of shade of gray where your life gauge is for your plane. If it's no longer black, then you're in a station and it's going to say the trip is done, and it's going to go ahead and exit our last loop, and the program is going to halt. Now if this is not the case, then it's not going to set running to false, and then it's going to go back up to the top, all the way up here to the beginning of our while loop, our running loop here, and it's going to go back through it again. So it's going to find yellow in that window again, and then it's going to go ahead and click on that, and then it's going to click on warp, or warp to 0 and then jump, and then it's going to wait for it to see yellow at the top of the list again, and then it's going to wait for that to disappear. And once that's done, then it's going to once again just keep doing the process over and over again. Now I've found that this works very, very well. It's a very simple program, but you don't have to make things very complicated in order for them to work. It's just trying to do something very simple for you. Now if you are making this a mining bot, then you may want to make it a little bit more complicated, and I have actually I've messed around and I've done so myself a little bit, but that's another video. If you guys want to see it, let me know and I'll show you how to do it. But like I said, as far as this goes, this program makes it so that you don't have to use the sorry autopilot that CCP provided, and that you can actually use one that you created yourself, and you can save yourself the time and effort of having to sit down if you're making a long trip, or especially if you have a freighter, and having to sit down and wait and clicking on jump every single one. And also you don't have to worry about the slow dock time where the ship has to slow boat it over to the jump gate. Now, and I'm just going to make one last point on this, all right? If you have watched this video and you're still a naysayer and saying, you know, you're dumb, why are you making this program, and why are you doing something like this, you know, and if you don't feel like doing it, you shouldn't play the game. Well, then tell me this, you know, if CCP doesn't like botters and different things, well then why in the heck did they make their own bots to police the system? You know why they made their own bots to police the system? Because there aren't enough people who they hired to sit there to look and see who's doing illegal activities on the server. And even if they did have enough people to do so, it wouldn't be worth their time to do it, because you know what? More likely than not, there's no one doing anything illegal in the system. And you know, so why do it? You know, they're making the most out of their time. Why don't you make the most out of your time? Why don't you make a program that warps for you so you don't have to do it? All right? Have a wonderful day. And like I said, the source code will be on the bottom of this video.